Hello and welcome to our last session in this playlist on math for elementary school teachers, where we are just going to see slightly more advanced word problems for our level that can be done with variables and equations. So if you talk about variables and equations in a word problem setting, problem, then I want to keep the four main steps in mind for how I'm going to go through this word problem. Now, we've discussed this before, but the first step is clearly define your variables. What are you going to call them? What quantities are you going to associate variables with? That has to be clearly explained before essentially translating the English words into this mathematical language of variables and equations. Then, after we've done that, we want to, let's focus. It's very much a translation. Translate the words to hopefully just one equation. But you'll see sometimes when we have independent quantities that we don't know, it is necessary to have multiple. But I'm always going to aim to minimize the number of equations, number of variables. Then we're in this mathematical language of variables and equations and algebra. We can solve the equation. And of course, that depends on what the equation looks like. We can't say, oh, it's always going to be this, it's always going to be that. No, it depends on what it looks like. And lastly, I'm going to get an answer, but it's really an answer in the mathematical language. I want to relate that back to an answer in the same language as the original question. So I will write a concluding sentence just saying in English again, this is my answer. If you didn't understand the math, you can still read the question, read my answer, and at least know what the answer is. So we're going to do this just by example. We're going to look at, let me see if I can zoom this a little bit. I think I can. Exercise 1622 is first. And hopefully with these, I mean, you can always do more, you can always find more at other websites and other resources and books, but these will give us an idea of the level that we're aiming for. Okay, let's go. 56 biscuits are to be fed to 10 pets. Each pet is either a cat or a dog. Each dog is to get 6 biscuits, and each cat is to get 5. How many dogs and how many cats are there? Now, yes, I'm not saying this is a super advanced question, and you can certainly guess and check your way through this. But sometimes the numbers aren't as convenient to support a guess and check strategy. Our backup, foolproof method is with variables and equations. So what are we looking for? We're looking for ultimately the number of dogs and the number of cats. So pick one. Say dogs, because it was first in the sentence, and we'll say let X represent the number of dogs. Do not say let X represent dogs. X is not an animal, it is a number. So you want to clearly emphasize that you understand what a variable represents and how it is used. Now, in the interest of keeping things as simple as possible, I want to minimize the number of variables. And I can do that because the number of dogs and the number of cats are not independent of each other. I have a total of 10 pets. So if X is the number of dogs, then the number of cats, the number of cats is 10 minus X. I'll put brackets around that just as a container. And that's going to make my life much easier. So I want to take care here and write full sentences, make it clear, start out on a good note. Now I want to translate the sentence or the concept that 56 biscuits have to be fed to these pets. Each dog gets 6 biscuits. So I'm going to calculate the total number of biscuits in 2 ways. The left will be total, where's my C? Biscuits. And the right will also be total biscuits, total number of biscuits. I know that's 56 from the question, but if I can break it down to dogs and cats separately and add them together. Each dog should get 6 biscuits. If there are X dogs, that is 6 times X. Each cat should get 5 biscuits. This is the number of cats, so 5 times the number of cats. And those should equal each other, giving me a mathematical sentence that translates, that captures the same concept. Now in the mathematical language, I have steps and ways to simplify sentences like this. I want to multiply the 5 into the bracket first, equals 56. Then perhaps I want to put the, not perhaps, I want to put the 2x related terms together, and 6x's minus 5x's, just an x. Subtract 50 on both sides to give me a 6. Now, that is essentially the answer, but it's not complete. It's not really in a language that the question had. So I want to just wrap it up with a concluding sentence saying there are 6 dogs because X corresponded to the number of dogs, and therefore 4 cats. And now I'm done. So even if someone doesn't quite understand this middle mathy part, they can read the question, they can at least understand my answer, not necessarily how I got it, but at least make sense of what the answer is. So that is the structure I want to keep in mind in general, really, but more importantly, when it comes to variables and equations. Now I may be going a little bit fast for your liking. Remember, you can always pause the video, look back, watch it over and over and over if you can stand my voice, that is. Let's do the next one. 1623. I should have put a calculation in chat. I'm sorry. The chat box is fairly empty because this is just a recording, not a live stream. Early in the morning. In planning for a conference on successful small business practices, the organizers are anticipating that twice as many men as women will attend the conference. If they are expecting 600 to attend the conference, how many men and how many women are likely to attend? Now, in fairness, there are 2 ways to approach this because both of the concepts are fairly simple. Regardless, I'm looking for the number of men and number of women. Let's say W represents the number of women to attend the conference. Do I have to have a brand new variable for the number of men? Because I need to know that number as well. No, I don't. Now you can go one of 2 ways here. You can say, well, there are twice as many men as women, and that's the first thing we get, so why not just go with that? Twice as many men as women. So then the number of men is going to be 2 times W. There's twice as many. Now the other piece of information refers to the total number of people, which is 600. So if I add up the number of women plus the number of men, I should get 600. So the information that they've given me that I have to translate to this equation, fairly straightforward. You could have done it the other way around, very similar situation. And now in my mathematical language, I have 3 times W equals 600. So W equals, divide both sides by 3. Let's pretend we don't know, so MathBot has something to show in the chat. Though maybe later there will be a calculation that it's calculator worthy. I just wanted to show something in the chat. And of course we get our 200. So it really depends on what the equation wants me to do in that mathematical language and system. I have my answer, so I could write my concluding sentence. There are 200 women and twice as many men, so 400 men. And I can definitely check that it does add up to 600. A very simple check in this case. But notice how the procedure, the steps are the same. I establish and emphasize those steps and build the habit in these easier questions so that when I come across a complicated question, I don't get all frazzled and confused. I know my method. I know my 4 steps. I can rely on that, and it gives me confidence that I can work my way towards the answer. Kids especially are very concerned with finding the answer, the final answer, when in fact the journey, the procedure, the story through the question gets me to the answer. I don't have to obsess about the answer. I've seen this. Grade 2 arithmetic, where I start doing 2-digit plus 2-digit numbers or 3-digit numbers. They want to get the answer immediately. No, systematically work towards the answer, and it's going to reveal itself. There is never anything I have to worry about. The equation is going to show me the answer. If I set it up correctly, then there's nothing to worry about. I don't write my first sentence knowing the answer. It's the first part in a story that I have to go through. Oops, we are out of space on that page. Excuse me. That was unfortunate. So if I just trust the procedure, trust the system that is in place to help me get to the answer, things will seem much less intimidating. Next one, 1624. Diane's card shop spent a total of $950 ordering 600 cards from Wits End Company, whose humorous cards cost $1.75 each, and whose nature cards cost $1.50 each. How many cards of each style of card did the card shop order? Okay, well, I don't care about the whole question and whatever. I care about what is the unknown that I'm trying to find. Let's get that a variable name. So there are 2 things I want to find. How many humorous cards? How many nature cards? Oh, all right. Which one do I want to pick first? I don't really care. Humorous came first. So we could pick an H, maybe a capital H. Humor. You can use any symbol you want, of course. Let that H represent the number of humorous cards. Do I need a new variable for the number of nature cards? I certainly could. But then I'll have 2 equations, and that bothers people at this basic introductory level. So my aim is always to minimize the number of variables, and in doing that, the number of equations, keeping things as simple as possible, and very often I can. They say we have a total of 600 cards. Therefore, if I know the number of humorous cards, the number of nature cards is 600 minus h. And it's just going to make my life simpler later. These two numbers are not independent of each other, in the sense that if I have one, I'm going to have the other one. They're connected. And when I have that, I can get away with just one variable. Now, the other information that I haven't translated yet is the total dollar amount. So the total dollar amount will be how I construct my equation, where I look at the total cost on both sides. I look at it in two different ways. I know it's $950, but how else can I get to the total cost? By looking at the type of cards separately. Humorous cards cost $1.75 each, and I have h of them. So $1.75 times h will be the cost for all the humorous cards. Then $1.50 each for the nature cards will give me a total of $1.50 times the number of nature cards, whatever that is represented by. Doesn't matter right now. It matters now when I go into simplifying this mathematical sentence, this equation. So 175h plus 150 times 600. Just in case people need it, I will put it in the chat box. 900 minus 1.5h equals 950. Now I can put the h terms together to get 0.25h. I can subtract the 900 on both sides. Whoops, then it just becomes 50. So h is going to be, let's just confirm that 200 in case you don't care for mental arithmetic. I always try and do a little bit to keep myself sharp, but it's certainly not a requirement. 200. And that is it, a concluding sentence, and I'm done. It's always nice to look at the question and check. What were they asking again? I want to phrase my concluding sentence in a similar way to their question sentence. How many of each card did the card shop order? So, okay. They ordered 200 humorous cards and therefore 400 nature cards. Even though the answer is very similar to the previous question, the information was different, the equation looked different, and I handle whatever information is given to me. But the story, the process, the steps are the same, and that's what gives me confidence. I can have a very complicated situation. I know what I'm going to do. I'm going to start with my variables. I'm going to translate the information to an equation. I'm going to look at what that equation is and handle it appropriately, and the answer will reveal itself. There is no need to panic. No need at all. Variables and equations serve as a warm blanket. It's comforting. I know that it's going to get me to the answer. I just have to trust it. And I take a lot of comfort in that. Something people think may be funny, but it's true. 1625. Is that the number we did? Yes. Okay, good. That's our next one. A certain pet shop sells large birds and small birds. Each large bird fetches twice the price of a small one. A lady came in and purchased 5 large birds and 3 small ones. If instead she had bought 3 large birds and 5 small birds, she would have spent half, that's an H, $20 less. What's the price of each bird? So now the information is a little bit more convoluted, I'll say, but we don't care about that. We care about what is being asked. And I want to know the price of each bird. Okay. Now we have large and we have small. Let's go with an X again. Let X represent the price of, you can choose which one. Usually, to make things a little bit easier, though there is no real difference, it would be a bit more convenient to choose the smaller of the 2 amounts. I'm not looking for number of birds here. I'm looking for the price of each bird. Now, if a large bird is twice the price of a small one, the small one is the cheaper one. And it's just going to make things look a little nicer. It's not necessary to do it this way. Let X represent the price of a small bird. It's very important to write out your sentence clearly so you know, and anyone who reads your answer knows this is what my variable represents. There is no confusion. But if you just say X small bird, that's not clear. And it can create confusion for yourself when you look back at this question and study from it maybe, or to anyone who's trying to understand your question. Now, I don't need to define a brand new variable because the prices are obviously connected. A large bird is twice the price of a small one. So then a large bird costs 2x, twice the price of a small bird. Now the information needs to be translated, and the information is a little bit tricky. So when it is more complicated, I just have to go slowly. But what I'm trying to do is the same thing. Okay, so a lady came in, purchased 5 large birds and 3 small ones. Let's just see how much she would have paid. So this is 5 large, 3 small. Cost. What is the total cost? Total when she orders 5 large birds. Well, each bird costs $2x. She ordered 5 of them. So 5 times 2x. Also 3 small ones. 3 small ones at x dollars. Put multiplication signs in there, put brackets. I don't care how you write it. There's more than one way. Another scenario is where she bought 3 large and 5 small. So 3 large, 5 small, total cost. Well, we do it in the same way. 3 large at $2x each, 5 small at x dollars each. So now they tell me how these two total costs compare. They say, if she did the second scenario, she would have spent $20 less. So now I want to put an equal sign here. You can decide which side do I want to adjust. Right now, it's not equal. Right now, it's not balanced. The second scenario is $20 less. So to bring it up to the first scenario, I could add $20, and now I have an equal sign here. Let me fix that. You could have also subtracted 20 on the left, but I need to bring these in balance. An equation is a balance of two sides. The second scenario, she would have spent $20 less. So the second scenario is less than the other one. Think of a balanced scale here. The right side weighs less, so it's a little bit higher. What do I do to put it level? I add weight. Then it's level. Okay. Now I have an equation. I need to solve the equation. So I'll simplify. This is 10x plus 3x equals 6x plus 5x plus 20. So I don't want to go too fast here. I have 13x on the left. I have 11x on the right plus 20. I'm going to subtract my 11x's on both sides to leave me 2x's on the left, and that equals 20. Divide both sides by 2, and obviously x is equal to 10. Just to keep everything on the screen, I'll write my concluding sentence over here. Now it's good to check the question. What is the price of each bird? Okay, so the price. X represents the price. So a small bird costs $10. A large bird costs double, of course, $20. And I'm done. And it's again, trust the process, trust the story through this question. And the answer reveals itself. There was never any concern. Like, oh, what's the price? What's the price? I don't care. It's going to come out of the equation. It's not something I need to be concerned with. And if we can, when it comes to problem solving, impart as teachers one thing, which is very hard to do, it is focus on the process, focus on the story. Don't focus on the answer. The answer is going to come out at the end of the story. You never have to worry about it. The answer is a result of the story that you go through. The story comes first. And I've seen this many times, that as soon as they talk through the story, it becomes so much easier. And as soon as they don't, it becomes so much more difficult. All right. So yes, we're doing these things, but we're also thinking about what it's teaching us. And even if I don't teach a grade with variables and equations in the curriculum, there is still a lot that I can get from practicing these questions. People are so focused like, oh, I'm never going to teach variables and equations. I'm going to do grade 1. Yeah, but you're missing the point. You're missing the point of what the thinking is behind these. This is just one setting. We could have chosen another one. And throughout the course we have. 1626. 1626. During a downtown parade, Timmy sold glasses of lemonade at 50 cents each, glasses of water at 25 cents each, and earned a total of $10. At the end of the day, he looked at the amounts of lemonade and water he had left and determined that he sold twice as many glasses of lemonade than he did water. How many glasses of each did he sell? Okay, so there's my question sentence at the end. How many glasses of each did he sell? So let's say W represents the number doesn't represent water, it's the number of glasses of water that is sold. Do I need another variable? Brand new variable? No. Look at this second to last line. He sold twice as many glasses of lemonade than water. So if W is the number of glasses of water, the number of glasses of lemonade is twice that. So the number of glasses of lemonade is 2W. Now, some people struggle with this. It's a matter of experience. Like the more word problems I do, the better I get at word problems. So it's frustrating in the beginning, perhaps, but it just takes time, patience, and I'm happy to discuss any of these problems further on our Discord group. Check the description to see how you can join that group. Now, there's some information, and it's about the total that he earned. Okay, that's going to be my equation. So the total money that he earned, I'll break it down and also know that it is $10. So I have my $10. Let's break it up into what he earned for water, what he earned for lemonade. So lemonade's information is first, 50 cents each. So now you have to be a little careful. Some parts of the information, some parts are given in cents, some parts are given in dollars. So we have to make sure that our units throughout the equation are the same. So you then decide, do you do dollars, do you do cents? I don't really care. I think the majority would maybe stick to dollars, and I've already done dollars here, right? So my unit is dollars. So if I do a calculation with 50 cents, I'm going to have to make that 0.5. So $0.5 for a glass of lemonade. So how many glasses of lemonade? 2W times the price of each will be the total amount of money. Number of glasses, price per glass. Then the water was sold at 25 cents each. Number of glasses, price per glass. So I can simplify this now. I have my equation. 2 times 0.5 is a 1W. 0.25W. I'm really just regrouping things. I have a 1.25W equals 10. So W, I divide both sides. Let's do it in the chat box. We haven't done much in a while. 10 divided by 1.25. And we get 8. Again, just to keep everything on the screen, I'm going to write my concluding sentence over here. I double-checked the question. They wanted the number of glasses. Okay. So he sold 8 glasses of W. W was water. Water. He sold twice as many, 2W, 16 glasses of lemonade. Done. There's nothing that has to be hard or confusing if I go through the steps and trust the story, trust the procedure getting me to the answer. Okay, so hopefully you get a feel for the difficulty we're aiming for. I added 2 more exercises here just as examples of things being a little different. 1627. is not always exactly the same, and with time and experience, I will get that flexibility to handle more variety. Here are two examples. Joni left St. Louis on the interstate, driving west towards Denver at a speed of 65 miles per hour. Half an hour later, Kelly left St. Louis on the same route as Joni, driving 78 miles per hour. How long will it take Kelly to catch up to Joni? Now there's a hint. She catches up. They've traveled the same distance. But a very common setting for word problems that is so difficult for kids, and maybe some teachers as well, is this distance time traveling setup. A train travels west at a certain speed and another train travels east and they meet each other, and those kinds of questions are very scary for people. This is one such example. Now, there isn't a specific template to handle absolutely all of them, but most of them can be done in a similar way to this one. So let's just draw a picture. I'm driving west to Denver, right? So I have my two locations, a line connecting them. Okay, here and here. Okay. Now let's see. They want to know how long will it take Kelly to catch up to Joni. So they're both going at the same. Who's going first? Joni is going first. So here's Joni. There's her car. I don't know how to draw a car. That's not bad. There's Joni in the seat here. Front seat. Joni. Traveling. Good. Then a little later. So then let's suppose, a little later, Kelly leaves as well. Same route. Different speed. Okay, so let's put in the miles per hour for Joni. 65 miles per hour. Then Kelly leaves as well. Maybe Kelly's on a bike. I don't know how to draw a bike. That's a bike? What's this? I don't know what that was. There's Kelly, hair in the wind. Okay. Kelly goes at 78 miles per hour. Obviously a little faster. And she is eventually going to catch Joni because she's going to go half an hour later. So eventually they're going to meet each other. Let's suppose here they meet. Okay. Now this is hard for some, so I don't want to go too fast. I want to sort of paint a picture of how we approach this. Picture helps a lot. That doesn't even look like an H. That looks like a U. Come on, man. Come on. I'll take that. Okay. Question then. How long will it take Kelly to catch up? So if I know the time it takes, if I have the time it takes to travel from the starting point to the meeting point, then I would have the answer. Now, it doesn't matter which one you pick. We can pick Kelly, like the question asks. So let's say X. X is going to represent the number of hours that Kelly travels. Starting point to meeting point. Okay, that's where she catches. Meeting point, catching point, whatever you want to call it. Okay, so now I have to use the fact that in a basic situation, not speed, or at least average speed, is distance over time, which is why we say miles per hour. Miles over hours. Okay, so that's the basic formula that I want to keep in mind. So that then means that if I multiply both sides by time, a distance is calculated as speed times the time. Okay? And the distance that they travel is the same. This is the same distance. So that gives me an equation. Let's say here my equation. So fair. In case you were wondering, I don't care to know how long it took Joni, because they only ask how long will it take Kelly to catch up, but I will say, because I need it, then Joni travels for how long? Well, Kelly travels X hours. Joni travels half an hour more, so X plus 1/2. Just to be complete. Okay, so we are going to construct an equation by comparing distances. So the distance that Kelly traveled is going to be the same as the distance that Joni traveled. So what is the distance that Kelly travels? I'm going to use this. Distance equals speed times time. The speed is 78 miles an hour. The time is X. I'm not sure why I put it so far to the left. I thought there was going to be more to it. Sometimes there is. Ugly 8, come on. 8. X. It's going to be the same as Joni's distance. So, the distance that Joni travels, speed, 65, times time, X plus 1/2. There's my equation. Now I'm in my algebra equation simplification, mathematical language, and I just do what needs to be done. Multiply the 65 in. Oops, where's my X? I'll put some stuff in the chat box because it's been a while and MathBot gets a little lonely. 65 divided by 2, if you will. Get that line out of there. 32.5. Then I'm going to subtract both sides. Subtract 65x on both sides. 78 minus 65 is 13. So 13x's equal 32.5. I am running out of space. I'll do it over here. So x is then 32.5 divided by 13. That's not going to be a nice number, is it? 32.5 divided by 13. No, it is not. Oh, it is. They have made our lives nice and easy. We do get conditioned to think, oh, the answers always have to be nice and pretty and roundish. And then when I see a weird non-repeating decimal, I think, oh, it must be wrong. So it's nice to see. I was hoping for something a little stranger, just to get used to that as well. But that's not the case, and we do try and avoid that at an elementary school level. Okay, so this means I check my question. It asks how long did Kelly travel? How long did it take her to catch up? That's exactly what X is. So it took Kelly, that is a K, to and let's write it like this. Let's write it in words. It's nice. 2 and a half hours to catch up. Very different question. Absolutely. Very different. But variables and equations can still be used. The distance, speed, time, often with trains for some reason, is very intimidating, but it's often done like this. So this example is just a reminder that there's some variation that I certainly want to be able to handle. And my story, notice, my process didn't change. Variables, equation, solve the equation, concluding sentence. Nothing has changed. Nothing has changed. So I can handle much more than I think with this variable and equations method. Let's do one more. Squeeze it in. Squeeze it in. A river cruise ship sailed 60 miles downstream for 4 hours and then took 5 hours sailing upstream to return to the dock. Find the speed of the ship in still water and the speed of the river current. Different. What I want to keep in mind here is, again, my speed or average speed equals distance over time. Formula, a relationship, if you will. I want to keep that in mind. Okay, let's put that in the top corner here. Sorry, I didn't number this question. 1628. And if you feel that this video is too long, feel free to pause it, come back to it, Don't do a sitting for too long. It's a video. It's like people think, oh, it's an hour and a half video. I have to sit here for an hour and a half. No, watch it in chunks, do whatever you want. YouTube's going to remember where you were. So I am going to need a variable. What is something that I want to find? The speed of the ship. All right. Let X represent the speed of the ship. Now we use X again. X means something completely different than it did the previous question. Now, in an ideal world, like all the exercises we've done before, I would like to get away with one variable. But in this case, that is not going to happen, because the speed of the ship and the speed of the current are completely independent of each other, and there's no way to, in an easy way, to link them. That is not really a concern. I'm simply going to define a new variable. Let Y represent the speed of the river current. All right, so how does this work? Well, there's my river. River. And let's suppose the river is flowing a certain direction, of course. If my boat, I'm not going to attempt to draw a boat, if my boat is traveling with, let's say here, boat is traveling in the same direction, then the boat speed is going to be x plus y. But if it's traveling in the opposite direction, then the effective speed of the boat for a person standing on the river bank and measuring this, the boat is traveling much slower, because for the x that it's moving forward, it's moving backwards at the same time. So its net speed, its effective speed, is the difference between the two, x minus y. Okay. So depending on which direction the boat travels, the river has a positive effect or a negative effect, an additive effect or a subtractive effect. Okay. However, in both cases, the distance is the same. It's traveling 60 miles one way or the other. One way just takes it longer. The distance didn't change. So again, we are going to compare distance. And just like before, distance is then speed times the time. So let's say the distance with the current is going to be the same as the distance against the current. Against. They're going to be the same. So now I just have to use my variables to represent this situation. Okay. So distance is 60. Let me think. What's the most efficient way to do this? In this case, we're going to separate them. They are the same, yes. But let's see what this does, actually. This is good. This is a good little happy accident. Let's see what this does. Let's go. Let's go. So in this setup, I am ignoring the 60, really. The 60 isn't going to play in here. But let's do it this way and see, because that sort of links to what we've done before, and see how is it better, how is it worse. Yeah, it's a good idea. Because one question to the next, as much as I want them to be the same, they might not be the same. So let's see. So I'm traveling downstream, so with the current. With the current, I'm traveling for 4 hours. So my distance is speed times time. Speed with the current is x plus y. Time, 4 hours. Distance against the current, upstream, took 5 hours. Speed, if I'm against the current, my speed is x minus y. And it took me 5 hours, and those are the same. But now I have a single equation and I have two variables. So that means that this isn't quite the same as before, unfortunately. And the way they give me the information has to guide me to how to approach this situation. In general, if I have two variables from the start, I'm going to have to come up with two equations. And this method that we've seen before gives me one equation. But it's because I have sort of merged these two equations. These sides are really their own equation. This side is 60. This side is 60. And I can separate them by saying x plus y times 4, that's the speed times the time, equals the distance. That's one equation. And I need to have two equations because I have two variables. So the way the information is presented, I can't quite do it exactly the same as before. The right side information, the upstream information, allows me to write another equation. And those are two equations. Equation 1, two different pieces of information, and I need to handle them separately. So I'm not going to merge them together into one equation because I need to, because I have two variables. So because I started this way, I didn't have a choice. I am aware I'm going to need two pieces of information. So it's not quite the same as before. Now, how do I handle two pieces of information? Well, First of all, let's simplify this as much as we can. I multiply the 4 in, 4x plus 4y equals 60. And the other side is 5x minus 5y equals 60 as well. Now they look very similar, but one's a plus, one's a minus, and that makes a huge difference. So a simple way to go about solving these two equations is to look at one of them and solve for a variable x or y. Let's solve for, doesn't matter. Let's solve for y. So 4y equals 60 minus 4x. Now the two equation case is obviously more complicated. Yes, it's a step up, which is why I leave it at the end, just sort of as a thought, be aware of it, but it's a little beyond our difficulty perhaps. You can explore this further if you so desire. Now I'm going to divide both sides by 4. So y equals 60 minus 4x divided by 4. I have two terms. I can split this up and say it's 60 divided by 4, which is 15, minus 4x divided by 4, which is x. Okay. So it's just a rewrite of the first equation, of the first version of equation 1. It's the same information, but now it's a little bit easier to work with. This says that the value of y is the same as the value of 15 minus x. So wherever in the future I see a y, I can replace it. They are the same. 15 minus x and y are the same. They're interchangeable. So I'm going to replace it, this y in the second equation, with its x equivalent version. And then equation 2 becomes 5x minus 5 times 15 minus x equal to 60. But now I have the convenience of having just one variable in this equation. Now let's simplify this a little bit. 5 times 15, maybe MathBot needs some attention. Why not? 5 times 15. Good job, MathBot. Way to contribute. 75, it's a minus, so it's negative 5 times negative x, so plus 5x equals my 60. Put the x's together for a 10x. Add 75 on both sides for a 135. And therefore x is 13.5. Then I go back here and say, well, I know the relationship between x and y. So if x is 13.5, y is 15 minus 13.5, which is 1.5. So here I have my answer. Now it's a matter of the concluding sentence. The boat, not boat, whatever, boat speed, boat ship, whatever, boat speed, because that is what our variables represented, the speed is 13.5 miles per hour. The current or river speed is 1.5 miles per hour. So definitely a step up. I do not disagree with that. I'm going to have to zoom out twice to see this question in its entirety. That cannot be a good sign. Definitely a step up, which shows why we want to avoid the two variable situation as much as we can. I am just making my life so much worse. And at our level, very often, if not all the time, we can avoid it. But there are some cases where the quantities that are missing are independent of each other, two variables. Trying to avoid it in that case makes things even more confusing. There comes a point where I have different pieces of information, resulting in separate equations. And this process of elimination of one variable into the other equation is a standard way to handle it. It's not something I can avoid all the time. As the difficulty and complexity increases, it's gonna happen. Does it happen in grades 1 to 7? No, probably not. So be aware which way this is headed, but also don't be concerned because my aim is to teach at an elementary school level. But hopefully that gives you an idea. Focus on the story, not obsess about the answer. Join our Discord group. Contact me with any questions. Read the description to know more. And I'm happy to hear from all of you if you have any comments or questions. Until next time then, thank you.